So this is the solutions on how to do the Chapter 8 practice test. So exponent notation. Remember, we had it was back at 8.6. If you have those notes, if you will look at that, you can. I forget exactly what letters I used. It was something along the lines of like, you have x raised to the a over b. That's the same thing. B root x to the a, or vice versa. So you will not get that on your test. You need to have that memorized. Really, I think that's the only formula you have on the test, so it shouldn't be, and it's not super long. You will have to commit to your memory. So let's get rid of that. You put it in exponent form. B raised to the numerator is your exponent. The denominator is your index number, and then make sure you reduce that. So 2 over 4 raised down to 1/2. That is your answer. Same thing with this next one. That is n raised to the 2 over 6. When we reduce to that, that is n raised to the 1/3. Write this one in radical form. So I always start with my radical, and then I put my x, or your base number, whatever that is. Then my index number is the denominator, and the numerator is my exponent. Now remember, you can also write this one with your exponent outside. That's fine too. Either way, it doesn't make much difference. So moving on to the simplifying problems, and this is obviously the bulk of this chapter, or the bulk of this. Doing this one, I'm splitting it up. Third root of 40 and the third root of x to the 4th. Exponent sheet, if you have to, you will get one of these on the test. I'm probably not going to do the exponent sheet every single problem today or on this video, but since this is our first one, we will. So I'm looking for the third root. Means I'm using the third column. One of these numbers that is a factor of 40. So the best way to do it, 40 and 64. You're not going to try bigger. If it's bigger than 40, it can't be a factor. So then in your calculator, I just take 40 divided by 27. That gives me a decimal, so 27 is not going to be the one I use. 40 divided by 8. 40 divided by 8 is equal to 5. That means we're going to use 8 times 5 to be 40. With your table, if you go all the way to the left, that is the third root of 8. So the third root of 8 is 2, and then we can't do anything with that third root of 5. We want a number, a multiple of 3, so 3 times 1, 3 times 2, 3 times 3, 3 times 4, 3 times 5, 3 times 6, so on, so forth, so on. Now going over, that's got to be 3. So I'm going to change this. Instead of x to the 4th, I'm changing it to x to the 3rd. But you can't just do that. Change the 4 to a 3. So we need one more x to make sure we have all 4. So we have 3 of them, then we have 1 of them. We do that is because now we can 1, so that's just x to the 1st. Yeah. Everything that's not in front, everything that is inside of a radical goes together all in the same radical. X times the third root of 5x. We have the square root of 50 and the square root of x to the 5th. You do not have to break it up this way, but I think it's not a bad idea to do, especially if you struggle with these. So 50, if we go squared column, so 50 is right. And again, now you take 50 divided by 49, that's a decimal, so 49 doesn't work. 50 divided by 36 is a decimal, so that doesn't work. Or 25. So I'm going to change this 50 to 25 times 2. And again, the whole thing, when you have those two numbers that multiply to be 50, one of them has to be from our list. So I couldn't have used 5 and 10 because 5 is not on our list, 10 is not on our list. They do multiply to be 50, but we need one of the numbers has to be from our list. So that's why we chose the 25. And the square root of 25 is 5, so this ends up being 5 root 2. And we might as well, that doesn't make any difference. So then 3 times 5, we didn't do anything with 3, is 15, so that's 15 root 2. Then go back to the variable. So again, they don't have an index number. That means it's a 2. A couple people have been putting a 1 there, and I get it because a lot of times if there's no exponent, there's a 1. If there's no denominator, it's 1. If there's not a number in front, it's 1. I get we do 1s for a lot of that, but 2 is the one for square roots. So make sure you're careful with that. So a multiple of 2 as close to 5 as I can get without going over has to be 4. If I have 4 x's, I still need 1 more to get my 5. Then 4 divided by 2 is 2. So you end up with an exponent of 2. Again, that makes the radical cancel. Then we can't reduce anything with that square root of x. So when you're finally done, everything that's not inside of a radical goes together, 15x squared. Everything that is inside of a radical goes together in one radical, 2x. It doesn't look like we can combine. Remember, when we add or subtract these inside the radicals, those have to be the same to be able to combine those. So they're not the same, so we can't, but we have to reduce them. That's the whole idea. When we reduce them, then you're going to be able to combine some things. So if you use your exponent, we're dealing with the third column. So 250 would be right here. 216 doesn't work, but 125 does. So it's 125 and 2. So 125. If you want to go ahead, I have the third root of 125 is 5. Subtracting from that, 92, 192, you're right here. 192 divided by 125 doesn't work. 192 divided by 64 does. 64 times 3. Or times the third root of 64 is 4. Root. So that's last but not least. The 3 is already reduced as much as it could be. Use your exponent sheet. The 3 would be right here. And it's too small. There's no other numbers that are factors that are. We end up with root of 3. Now that we're done reducing, now all of a sudden you can see if they have the same radical, you can combine those. So 25 times the third root of 2, you can't do anything with that. But then negative 12 plus 7 is negative 5, and then the third root of 3 doesn't change. So 25, third root of 2 minus 5 times the third root of 3. Now, number 7, please realize this is a multiplication problem. This is one that there's 2 different ways to do it. You can reduce your radicals first. So this 18 you could reduce first. The x to the 5th you could reduce first and then combine them. But I do not like that method. I highly recommend just multiplying them together first and then figuring it out. In subtracting, they had to have radicand. With multiplying, they don't have to. You can still multiply them. So we have 6 times 8 is 48. 18 times 10 is 180. And then x times x to the 5th is x to the 6th. Now is reducing. So I combine them first. I think that is a lot easier, but to each their own. So 180, I'm going to probably not use the exponent sheet as much, just because, again, you use it almost every problem. I guess it doesn't matter. 180 is the square root. 180 would be right here. And let's see. So none of these work, and I know it's 36 days. So that's how we're going to go a little bit quicker like that. So 180 is 36 times 5. 48 times 6 root 5. Multiplying it by the square root of 6, but we can divide. 6 divided by 2 is 3, so that's just x to the third. Multiply 48 times 6 together. That gives you a pretty big number, but that's okay. And last but not least, again, everything that's not inside a radical goes together. Everything that is inside of a radical goes together inside the same radical. If you look at the answer key that I made for this, I also did it the other way where I simplified those two other things first that I mentioned. But again, I would not recommend that way. A couple people that see this and they've asked and they said they didn't know how to do this. Most of you guys actually do. One thing I will tell you, you do not just take this and go to both of them and say, oh, that's square root of 5 squared, square root of 3 squared, so this is just 8. You do not do it that way. Squared, I just write it outside the top. Plus the square. So square root of 5 times square root of 5 times the square root of 9. So I know the square root is just 5. We have 1 root 15 and 1 root 15, so that's 2 root 15s. 3. Then number 9, we had the third root of 162. Again, if you get the root, 162 is about right here. If you do trial and error, 125 doesn't work, 64 doesn't work, but 27 does. 27 times 6. So this is 27, the third root of 6, and the third root of 27 is 3. So this one's just a normal reducing problem, not anything fancy with that. Okay, moving on. Some more adding and subtracting of 135. 125 doesn't work, 64 doesn't work. This is the third root of 27 times the third root of 5. 27 times 5 is 135. And then 6 right here on our list. And again, 216 doesn't, but 125 does. So this is root of 125 is 5. So remember, it has to be the same and they don't change. So 3 plus 5 is 8, and it just stays the third root of 5. Do not put the third root of 10 or the third root of 25. Remember that 5 doesn't change at all, but 6 times 2 is 12. The only thing with this one is once you have that, then you still have to double check to see if you can reduce, because the 12 and the 18 you can reduce. I'm hoping at this point, not that you don't need it, I think a lot of you guys still need it a lot, but some of you, at least, or hopefully a lot of you, are starting to be able to get some of these smaller ones. Times 2, so that's 4 times 3 root 2, which is 12 root 2. Unfortunately here, you cannot combine those. One is a root 3, one is a root 2, so that is your answer. Number 12. There is that property that if you have any multiplication problem that's raised to an exponent, that exponent goes to both the number and the variable. So we do that same thing here. That 2/5 goes to my number and my variable. So we have raised to the 2/5. You need to fully aware later hit enter and it gives you the answer. I totally understand that. I know you can do that, but I want to make sure you can do it by hand. So from here, I guess a lot of people say, well, I have a calculator with me. Well, if you don't have a scientific calculator on your phone, then it's a little bit more difficult to do these fractions. So to do by hand, you do I make it into a radical. So what we did earlier, put it in a radical form, your denominator is the index number, exponent. Now there's two different ways to do this. It doesn't matter. You can square the 3,125 first and then do the radical. I think it's easier to do the radical first. So the radical of 3,125 is 25. Sorry, the fifth root of 3,125 is 25. But you still need the square because we haven't squared it yet. Oops. Sorry, I'm jumping ahead of myself. Sorry. Rewind. The fifth root of 3,125 is 5. And that's what makes it 25. I looked at the wrong place on my answer key. Raised to the 20 over 5, which is z to the 4th. So your answer is 25 z to the 4th. Next, distribute the root 5, distribute the 3. Root 5 times root 5 is root 25. Root 5 times 2 is negative 2 root 5. 3 root 5, and 3 times negative 2 is negative 6. Putting these together, you end up with positive 1 root 5, which you don't really need the 1, 6. Then 5 minus 6 is negative 1. So this is negative 1 plus root 5. That's how I would write it. Reducing this is just the 4th root. So I split it up, 162 and the 4th root of x to the 12. Here. And that's got to be the first one is the try works is 81. So that is 81 is 9. The square root of 81 is 9, and it's an obvious mistake if you aren't going too quickly. The 4th root of 81 is 3, I believe. Over here, 12 divided by 4 is 3, so that cancels the radical. So your final answer for this one, 3x to the 3rd times the 4th root of 2. The answer key I listed out, your numerator and denominator. If you want to do that, you can. For this one, I don't think it's super confusing to not do it that way. So square root of 6 and square root of 6 is square root of 36. When you kind of do it, I think of it as backwards, but depending on how you want to look at it. That is 3 times root 6 is 3 root 6. Root 5 times root 6 is root 30. So the square root of 36 is just 6. And I guess I can walk you through it. Can you reduce the square root of 30? So 30 divided by 25 is a decimal. 30 divided by 16 is a decimal. 30 divided by 9 is a decimal. 30 divided by 4 is a decimal. So there's none of these that work. So that's as reduced as it can get. So that's your answer for that one. 2. 5 plus root 2. And this one I do think it's very beneficial to list out your numerator and denominator. So we have 3 plus square root of 2, 3 plus square root of 5 plus square root of 2. That is 2, 4. Can combine root 2. The square root of 4 is just 2. So then 15 and 2 is 17. So 17 plus 8 root 2. That's just your numerator. Root 2. Negative root 2 and positive root 2 is negative root 4. The square 0 root 5, which cancels, so you don't actually have to write that step. I just didn't know if it was helpful to do that. Square root of 4 is 2, so 25 minus 2 is 23. So just don't forget then your answer for this one is 17 plus 8 root 2 over 23. Problems with this one, and I'll explain why once I'm done with this one. 2 plus root 7. Seven times 8. 7 is 49. Root plus the square root of 7. So that's 15 plus 6 root 7. Your denominator is root 7 times 2 plus root 7. So that's 4. 2 times root 7 is 2 root 7. Negative root 7 times 2 is negative 2 root 7. And negative root 7 times positive root 7 is negative root 49. So we have 4. These cancel. So if you want to put 0 root 7, you can. You don't have to. 4 minus 7 is negative 3. So your final answer, 15 plus 6 root 7 over negative 3. So the other thing that I'm going to do for this one, this is not on your practice test, but I wanted to show you for the, because I did put one on the test that was like this. Let me see if I can. Let me just do it this way. Let me erase all this real quick. Basically, both of these numbers, 16 and 17, are both fairly similar problems. And when I was making this, I just kind of had a mental lapse a little bit. The one I wanted to make this, the equation I wanted to use, and again, I just leave it like this, and that's fine, and you still can do that. But I wanted to make it something like 4 plus root 7 over 2 minus root 3, where the 7 and the 3 are different. So I did this one by accident, which is fine. Again, you still have to know that. It's still, there is one like that on the test, but I wanted to take this time. There is also one like this one on the test. So to do that, you do the same thing we normally do. Multiply by the conjugate. So that is 4 plus root 7 times 2 plus root 3. And this is, the numerator is the part that's a little bit different. And actually, I was not going to put one like this on the test, and then I decided to because it actually goes a little bit quicker. You'll see why in a second. 4 times 2 is 8. 4 times root 3 is 4 root 3. 2 times root 7 is 2 root 7. And root 7 times root 3 is root 21. That's it. That's your numerator. And so it looks kind of ugly because there's 4 terms there, but it's actually quicker because on the other ones, we had to do some work where we reduced things and combined things to get to where you finally got our answer. And this one, we already have our answer, or we already have our numerator. So I am planning on doing that on the test. And again, if you want to see, if you can tell before we even start if that's going to happen, if these radicals are different compared to if these radicals, if these radicals are the same. So your denominator is still, again, the same thing we've just done in the last two problems. So I'm going to go a little bit quickly through that. 2 times 2 is 4. 2 times root 3. Negative 2 times root 3 minus root 9. So that's 4 minus 3 is positive 1. So this whole thing over positive 1, which is just 8 plus 4 root 3 plus 2 root 7 plus root 21. If you leave it over 1, that's fine as well, but that's it. So it's not anything crazy. You just end up with something that's kind of ugly, but it's actually a little bit easier. So I wanted to put one on there, and I wanted to put one on the practice test, but apparently at 11 o'clock when I made this, I forgot. Okay, moving on. Number 18. Again, this is just another reducing your radicals. So separated 245 and n to the 9th. A little bit. Right here. But if you did trial and error, until you get to 49. And so some of these take a little bit of time, but it's just calculator work. 49 times 5. 5. I can get without going over is 8. So I need about one more to make up my 9. Then 8 divided by 2 is 4. Can't do anything else with that other radical. So you end up with 7n to the 4th times the square root of 5n. Number 19, again, you could try to reduce this before you multiply, and I actually do that on the answer key. I show you that way, but this one's actually really bad because if you do that, you can reduce this one, but then when you multiply, you have to reduce your answer again, so you have two reducing problems in this one if you try to do it that way, but it works out. That's fine. I'm going to multiply together first. So 8 times 10 is 80, and 6 times 144 is 864. Then reduce that radical. 864 it's the third root, so 864 is right here. Again, 729 doesn't work. That gets you a decimal. 512 gives you a decimal. And again, when I'm saying gets you a decimal, we talked about this earlier, but I'm taking 864 divided by 729. That's a decimal. 864 divided by 512. That's a decimal. 864 divided by 343 is a decimal. But 864 divided by 216 is 4. So this is 16 and 4. And the reason I picked from our list, the third root is 6. And last but not least, 80 times 6 is 480 times the third root of 4. If you are still struggling with the reducing radicals, I strongly recommend you ask questions, but also watch the lessons 8.1 and 8.2 for those. These are the solving ones. Now, I will tell you a couple things right away. One thing really quickly is with exponents. So 20 and 21, there are no exponents. You don't have to worry about those. The ones with the exponents, if it's an even exponent, you're going to have 2 answers or no solution. If it's an odd, you're going to get 1 answer. So before we even do anything, we can know those 2 little things. So going back to these, we're going to solve the radical by itself first. So subtract 12 plus 5 to 20 minus 12 is 8. For the radical. So since this is a square root, I square both sides. That cancels. Minus, because we did not cancel any exponents, there isn't any exponents. So just make sure you are aware of that. And then steps for problems. So we just subtract 5. You get x is equal to 59. Now again, remember, if you're somebody that really wants to make sure you get a good grade, whether you want to make sure you keep an A in this class or if you just want to get up to a 60%, whatever your answer is, if you want to do anything you can, if you want extra credit, take that 59 and plug it back in. 59 plus 5 is 64. The square root of 64 is 8. 8 plus 12 is 20. That works. We're good. It doesn't take very long to do that. And again, that's going to be worth more. If you catch some mistakes, that's going to be worth more than any extra credit I can assign you. That's right. Is equal to, then divide by 2. So on which one to do first. And it's the same thing as when we solve two-step equations. When you have 2x minus 2 is equal to 10. Get rid of the adding and subtracting, and then the multiplying, dividing. Same thing here. Squaring both sides. It's 3x minus 3 is equal to 36. 3x is equal to 39. Divide by 3. So this one, before I even start, I know I'm going to have either two answers or no solution. So from here, I would add 10 to both sides. So I have the third root of x minus 7 to the fourth is equal to 16. Now I cancel. It doesn't matter which one you cancel first. I always cancel the radical first, but it would maybe be easier to cancel out the exponent first. But I think the way it's written out, I think it kind of makes a little bit, it's easier to remember to cancel the radical. 16 to the third is going to be a big number. That's 4,096. From here, take the fourth root of both sides. Now, since we cancel out an even exponent, that is why we end up needing the plus or minus 8. So x minus 7 is equal to positive 8. X minus 7 is equal to negative 8. So you add 7 to both of these. One of them, you get 15. You get negative 1. So negative 1, x is equal to negative 1 and 15 is your answer for that. Two answers. This you'll get one answer. So to cancel out this radical, I square it. You get x minus 2 to the third is equal to 27 squared is 729. Take the third root of both sides. You get x minus 2 is equal to the third root of 729 is just 9. Then from here you add 2 to both sides. You end up getting x is equal to 11. Now the two things I want to add to this, then we'll be done. I didn't have any of them in here, but I took out basically a lot of these were squares, and we already did the problems. When we had square roots and we canceled those, we did problems like that already back in like chapter 4 or 5. So instead, I tried to make one of them to the third and maybe one to the fourth. But again, you do it the exact same way. We just did one to the third. The fourth, the only difference is to cancel out that fourth. Oh, where'd it go? You'd eventually raise it to the fourth power to get that to cancel. So that is all stuff you should know, but just to give you a heads up. And last but not least, I did put one, I think I put it as multiple choice, where you have an even exponent. And I tried to make it super easy. I forget what it was, but you ended up getting like third root of x to the fourth is equal to negative 10. You cannot, I mean, if you want to try to solve this, raise both to the third, x to the fourth is equal to negative 1,000. But when you try to take the fourth root, you can't do that because, again, if you have an even exponent, you could get two answers, but you can't take the fourth root of a negative. So this is no solution. So I did add one of those. I think I did it as multiple choice, and I tried really hard to make it so it wasn't like a lot of confusing work. I either made it a one-step equation or maybe I already had it set up to be a negative. I don't remember. So if you have any other questions, make sure you let me know. Other than that, good luck.